Hello everyone, Kenty Tiger here with Bengali Engineering and Play. We are back in Space Engineers, slightly off angle. So what I wanted to do is, so the goal for this this part is to build the production portion. So really focused in on refining as well as assembly. Okay, so getting my refinery portion and my assembly portion all set up and working. Um, so let's start with a little bit of a tour, because I had intended to do that and didn't. Leaking. Okay, that's actually going to stay leaking. So what we did last time was start with the setup of covering all of the build and repair systems. So we have the build and repair system in the top here, and ultimately I would like to put nanite control factories, and I think I'm going to put them right in front of the shield grids. But let's do the tour. So right now there are actually 3 medical bays. So we have medical room 1, and actually this is medical room 3, which is the outer pad. So medical room 1 and 2 are inside. So what I want to do is we're going to go ahead and add this into my systems medical group, and then we're going to turn it off on the toolbar and off in the terminal, because it just serves absolutely no function to see any of that. I think that was complete. So our medical, we have medical on this side, medical over here. We also have 3 cryo chambers on this side and 3 cryo chambers on the other side. So if for those who like to utilize worlds of other people, eventually I do plan to have this world on the workshop when it's all done. It'll take a little while, but it will be done. There are, as you can see, 5 connectors here. The idea was these are the small craft connectors. In this case, I have my miner sitting over here. Maybe you'd have a fighter or something like that. So there's 2 on each side, and then there's this center line. Now there's actually 4 on the center line. Why did I put them on the center line? Well, the bigger ships could come in here. Obviously you're going to have a little bit of restriction because this is a 7 high by it's 5 and 4, so it's 9, so it's a 7 by 9 chute here to get in and out, which is actually a little bit limiting. So if you're building big ships, your big ships may not be able to come in here. Some of them will. But if you're bigger than I want to say a 6 by 8, you're gonna be squeaking in, if you can make it at all. So problems. All right. I kind of went into some of the mods that are installed, and I don't really want to reiterate that so much, as this is all based on MMaster's automatic LCD scripts. So what we have here is a listing of all my ingots that are available, and you can see I've got a shit ton of those. So I've done a lot of mining and stuff ahead of time. Unfortunately, we have very little as far as components go. So I've got a long ways to go as far as components. The only thing we have quite a bit of, I'm using default as far as the default numbers here. You can actually go into MMaster's configuration and set up what these default values are. So this is your basic, how many are you going to need. So you can see these sliders, these progress bars here, are based on how much you have versus what the default is. So with these numbers, you should be able to build pretty much anything that you would want to build. This number down, cargo used, actually looks really, really silly, and I'm going to fix that off screen. So I'm not even going to mention what that is. It's something I need to take care of. Anyway, air vent. Let's go ahead and look. This is one of the features of MMaster. You go into custom data here. This command, oxygen, it displays pretty much the entire oxygen system pressurization status. So the system status. And what I mean by system is that all of these different components, these air vents in this case, so this outer draw, for example, are the ones that are on the outside. They're not intended, they are in the atmosphere. They are intended to pull in. And they're listed as leaking. These main space ones are leaking because the space is not sealed. So if you put armor against a voxel is not, you would think it's rock, some sort of substrate. You would think it would be airtight. It's not. Okay, the game does not interpret voxels as being airtight. The armor is airtight. So what the problem is because all the build and repair systems actually butt up against the rock. Let me go ahead and illustrate that. Just go over here. So if you look back here, this is voxels on the back. So just my bare rock on the back. So the build and repair system is butting up against that rock. The build and repair system is not inherently airtight, as you can see. You can see through it. So realistically, that does not hold air. So this glass that I put over the front of it is the airtight portion of that. So as long as those are not airtight, then this space, this great big huge main space, will be actually open to the environment. So it will not environmentally seal. All right. So medical we talked about. The build and repair system we talked about a lot in the last episode, the last part, so I won't go into that. Antenna. So this is the antenna out of my mod. The reason why I use that is because it was, I could have just as easily put a conventional antenna here. It would work. It's a base, right? Antenna is an antenna. If you're not confined by space, which is really the origins of why I did this, obviously you can tell this looks like an ore detector. So I used the ore detector model. I turned it into an antenna because it's a 2x1x1 block. Having a 2x1x5 block is a bit inconvenient when you're trying to build a ship, a large ship. You need an antenna for a lot of different reasons, or you can utilize an antenna for a lot of different reasons. So having a huge antenna with zero flexibility of size is kind of inconvenient. So I built one. So this is the base antenna, which is why it says KTC origin base. So that's the base antenna. Build and repair systems, 16 of them in the overhead here, which provides coverage for this entire space. And I do want to use the nanite control factories. I think I'm going to build them here in front of the shielding systems. Speaking of, these are the shielding systems. So energy shields, Cylons, something. Anyway, when I post this world, then I will identify all the different mods that are available here. So there's actually 6 of the large shield generators. So they provide an incredible amount of shielding. So there's 3 on the far side there, there's 3 on this side. This is EEZO's EEZO upgrade module, and it's a specialized module. It actually kind of takes the place of a lot of the other modules. So I use them exclusively because they work. So there's 3 different kinds of modules in the vanilla game. There's the efficiency module. What does the efficiency module do? Actually, is it still called an efficiency module? Yeah, power efficiency. Really, it basically it does the same work for less power. So that's the efficiency module. The yield module. What does the yield module do? The yield module can only be used on refineries. The concept behind the yield module is it will draw more usable materials out of ore for you. So let's just say these are arbitrary numbers now. You put in a kilogram of uranium. And let's say you get out of that kilogram of uranium a quarter of a kilogram, so 250 grams of usable uranium. So with a 50% boost that you might get out of a yield module, and it varies, it's not 50%, again, these are arbitrary numbers, then you would actually get 125 grams more yield than your standard yield, which means you'd actually get 3.75 grams, 3.75 kilograms, or 375 grams out of that original 1 kilogram mess of ore. So the yield modules help you quite a bit. On a refinery, you can actually put up to 4 yield modules because they're dual. They need 2 ports. These guys only need a single port, and they're dual-sided, which helps a lot. So anyway, EEZO's upgrade module, and there's 2 different ones. There's the standard upgrade module, which is it looks the same, and there's the upgrade module that works on the shields. So this is the one that works on the shields, but it also works on assemblers and refineries. So I use it exclusively because more bang for the buck. What is this? This is a program block. This happens to be the block that is MMaster script is running in. So that's all it's doing. The one on this side is actually a spare. Originally that was going to be for Whip's airlock script, and I've just not used it because there's really no need. I'm in an oxygen-rich environment, so I don't really need to run that script. So shields. It's an arbitrary number, but I want to go ahead and show you. This is called large steel generator number 1. Now, one of the things, if you put the colon here on the end of the name, it will actually give you the amount of shields that it can do, as well as the current status. So I don't know what this translates into. I truly don't know what that number is. Effectively, it's a damage coefficient. So this thing can take this much damage on this grid, or this grid can take this much damage, and again, I don't know that's relative to what. I have no idea. Before the grid itself is taking damage. Okay, so this is the amount of shields that ultimately you have. What does that translate into? 97,200,000. So quite a bit. You can see some of the numbers. Productivity in this case is about the shields. So effectiveness. So obviously a lot of, and again, I don't know how those numbers really equate to anything, but colon. Okay. Power. Okay, we talked about power in the other one. So this is the power. There's actually 4 large reactors, and these are my reactors. They're not the standard reactors. Why? No reason. I actually toyed with building the base entirely vanilla, and the only reason I didn't was because um, this isn't the goal here was not to create an entirely vanilla, which is challenging. I love building just straight vanilla things because it's a challenge to see if I can. Um, for the things that I put up on the workshop, typically I will build them vanilla because that gives the whoever downloads them and uses them the complete flexibility to do whatever the hell they want. Add mods, whatever they want to do. In this case, the goal here is a series. It's not about putting product on the workshop. So power. These are my reactors here. My reactors are really amazing reactors. You can see these can do up to 100 gigawatts each. Okay, so about 20 times the amount of the normal reactors. So just a large reactor, using the large reactor model, but there it is. So these actually are connected in underneath. So everything connects into this grid underneath. These guys do not have to because power is transmitted through the blocks themselves. So 4 large reactors, 2 on each side, 2 over there, 2 over here, and 32 batteries on each side. As you can see, this is 4 rows of 8. So 32 batteries on each side. When I configure batteries, and everybody has their preferences on how they set these lower things up. Semi-auto is an interesting thing, and I don't really care for semi-auto mode. What does semi-auto mode do? As a battery, it charges all the way to 100%, enters into discharge only mode, goes all the way to 0, enters into recharge only mode, all the way back to the top. So it continuously cycles from 100% to 0 to 100% to 0 to 100%. So when it reaches 100%, it becomes a power producer on the grid. When it reaches 0, it becomes a power consumer at max, and takes from the grid. Okay, so I don't like that. The reason I don't like that is that battery can shift over to recharge mode at the worst, most inconvenient time. I'm in battle, I need my shields, I need my weapons, and all of a sudden my batteries run out to 0 and I can't do anything because my batteries just went into recharge. So my batteries are literally taking all the power on the grid. I'm in the middle of combat. Obviously, I'm using power, and my batteries, stupidly enough, go into full recharge mode. They take all the available power on the grid, and I am screwed because, okay, so semi-auto is also completely stupid. Okay, so it's about 100% to 1 or 100% to 0. There is no intelligence there at all, so I turn it completely off. As you can see from this battery here, what is this thing doing? Current input and output. How can you have input and output at the same time? Well, that's the beauty of the battery running in normal mode. If there is power available, it will use it. If there needs to be power out there on the grid, it will supply it simultaneously. Okay, so the idea here, if you look at max stored power, is 10 megawatt hours, stored power 10 megawatt hours. Okay, so what this battery is doing in normal mode is pulling in the power it needs to maintain 100%. How is that an advantage? When I need power, I have it. Okay, I don't have to worry about boom, it's all of a sudden needing power because it ran down to 0 because it's in full discharge mode. It will maintain 100% charge until it's needed for something else, until it runs out of a source of power, whether that be a reactor or solar. Then, because it's always putting power out onto the grid as needed, it will do that. So in this case, all of my reactors are hot, they're running, so my batteries go up to 100% and stay there, which is exactly what I want. So my batteries will be, when I lose my reactors for whatever reason, when I lose my solar power for whatever reason, my batteries are already at 100%. So I'm now on battery power, but I have 100% of battery power when I run out. Okay, so when my reactors go offline, I'm already at 100%. I'm not at 4% because of this mysterious, magical recharge-discharge cycle. They're at 100% until I don't have any power, and then they start feeding the grid. Okay, so that's why I always run batteries in normal mode. Uncheck all these boxes. They will do what they need to do automatically, completely automatically, and intelligently. So this is a demonstration of that. It's taking power, it's feeding power, but it's maintaining that stored power at 100%, which is exactly what I want. All right, battery lecture concludes. All right, so this is my power section. I have my batteries. There's 64 batteries on each side. So obviously these are Kenti batteries. They are larger than the regular batteries, which only store 4 megawatt hours. The nice thing about batteries, they can put a boatload of power onto your grid when you need it. So if something goes into the barrage of cannon fire, whatever, then you have, that's the neat thing about batteries. They're like gigantic capacitors as far as their ability to put power onto the grid. They can far exceed. Reactors are, they can put a shit ton of power out there, no question about it. But once they reach the limit of their power output, that's it. They go to 100%, and that's all they got. So the batteries, because they can provide a lot more power, put a lot of power out there on the grid, then these guys can sustain much higher power outputs than your reactors can. Okay, what do we have over here? We have 2 gas generators on each side that work in parallel with one another. So all of them working together. We have a Kenti hydrogen tank. This is an overpowered hydrogen tank, and 2 oxygen tanks. Now, why don't I have a boatload of oxygen tanks and hydrogen tanks? Well, tanks and space engineers don't really work as tanks. Okay, tanks only affect the grid that you're on. Okay, normally you take, any tank in reality, when a tank is full, it will equalize with other tanks. Okay, so if I connect a empty hydrogen tank next to this one, the pressures within those 2 tanks will equalize. Okay, so I can actually draw from this hydrogen tank, for example, or rather, sorry, let me get my reticle on the actual hydrogen tank. It says oxygen, but that's because I can't do models. I've never figured out how to do models. One of these days I'll figure that out. So if I attached an empty hydrogen tank onto this grid and connected it into the conveyor system, then in reality, the pressure in this tank should equalize with the other hydrogen tank that's empty, and they would both end up at 50-50 if the tanks were the same size, right? Okay, doesn't work that way. Okay, tanks will not equalize with other tanks on the grid. They just won't. Okay, so that's a game mechanic that you just have to get used to. If you're an engineer and understand gaseous dynamics, it'll drive you absolutely crazy. It will totally trip your OCD thing, but welcome to space engineers. Okay, it's the problem with not having any actual engineers on staff with game developers. So these are Kenti gas generators, so they are very, very efficient and effective. So I won't go into much more than that. All right. So power, gaseous production, and main storage. So the main storage back here. Ultimately, everything is going to go to the main storage. Why did I build the main storage and I didn't build anything else? Because I had stuff that I needed to put into main storage. Okay, so basic stuff. There's not a whole lot in here, but I needed some place to put it. So that was the beginning thing. All right, so we have two things here. What happened? Okay, actually. So, why are these junctions, conveyor junctions, red? Okay, my convention is normally, and you won't see that at this particular base, but you will see it up on the station when I start building the station. I have 3 independent conveyor systems. One of them is main supply. Normally it will be green, and you'll actually see that out on the pad, the main landing pad out there. It's green. Or actually there's 2 that are the pull-in ones, which I'll get to, which is where we're going with all this. The green is my main supply. Unfettered access to these containers. Okay, that's why these containers are green, because they're the main supply. These guys feed into this main conveyor grid, main conveyor system. So all of these centerline connectors, all of the connectors short of the pull-in connectors are all interconnected. All of these are interconnected. All of these are interconnected. So everything is interconnected into that grid. There's nothing in between. There's no sorters, no anything. It's literally connected into the conveyor system. So I can pull items from any of these connectors, and I can push items into these containers from any of those connectors. Completely unfettered access. What is the difference between the pull-in? Well, the pull-in, which is the reason why it's red, is because if you connect onto this, the idea is that it's going to pull everything in that it can find. Okay, that's the idea of pull-in. So the idea is that I'm out on the pad. I set my miner down that I've spent. My miner's full. It's got all this ore and everything in it, and I set down and lock onto this connector, and boom, it pulls everything out of the miner and starts it into the processing. So that's the initial sorting mechanism. It's a pull-in. It pulls everything in. Why is it red? Because you might not want that. So you have this, let's say you have uranium storage. It's gonna pull it all in. There's no storage is sacred. It will pull everything available. It will absolutely empty out all of your ready access containers. Ice, you want to store ice? Nope, it's gonna steal it. So red, danger. Pull-in system. So I have painted my pull-in system red. Why do I have the red junctions in the floor? Because this is the beginning of my production area. It's presuming that these are raw materials. Now, the advantage of a fairly complex sorting system, which we'll get into as we really play here, is I can sort the finished stuff. So I can push the components, the hand tools, all that sort of thing, right straight into these containers by using the sorting. So we will have a reasonably complex sorting system here on top of our pull-in system. And that's just, it's the reason I want to do that is because I want to have the utmost flexibility in making everything happen. So we have a supply, which is that green connector out here. Let's go ahead and have a look at that. So my green connector, this is the integrated into the supply system. These red ones are pull-in. So I can land 2 miners at a time here and be able to pull in all that ore and everything, raw materials. It doesn't matter. So that's why these are red.
Energy low.
Oh, suit energy is low. This is why I have. Why I have the medical thing out here. All right. Back inside we go. So, the first thing we need in any pull-in system is going to be our storage, as well as a sorter. So let's get on the correct color here, which is the dark red. The first thing I want to do, just because I don't like putting sorters directly on the ground, is a conveyor tube. Then the next thing we're going to put on top of that is a conveyor sorter. Now, I don't use. Okay, I just had to figure out where the. Okay, conveyor sorters. I hope it's obvious on the screen here. Let me get turned angle correctly. This big arrow. Okay, the arrow points in the direction through which cargo material stuff can flow. Okay, it cannot flow in opposition of the arrow. It only goes in that direction. Now, conveyor sorters are really neat, handy devices. We might have to build backwards. So, conveyor sorter. We will eventually be able to configure this sorter. Can't do that now because I literally do not have the materials. I'm out of materials. So here's what we're doing. We're going to put the elbow on here. We're going to do another elbow, and ironically enough, yet another elbow. Why do I want to do that? Because my containers are a particular size. Okay, so 2. And this is going to be bolted into the floor and bolted on right there. All right, so this is a sorter that's pulling from the sorting conveyor. So we have the conveyor into the sorter and then into this guy. Now, I could have, in fact, maybe I should. No, I'm going to leave that. And here's where I was thinking. No, I'm changing my mind again. So let me do this. I'm going to. So what we're going to do is build that container actually up against this, and we'll go in on the top. Okay, so we'll put that in the middle. So this is the. So this is just going to look a little better, and so we'll go back. We do the one, then we do the elbow. We do the elbow here. Straight through. All right. So a little bit more efficiency, straight through and dump. Okay. And then we're going to mirror that on this side. So we have our one. In our next, we have our 7. So the let me go down low so we can actually see why am I positioning this. A little hard to see, but you can see the control panel that's obviously I'm moving here. In fact, let me go ahead. Well, I can't. Darn it. The control panel. So if we look in this little indentation here on the bottom that's just to the left of my reticle, there's a control panel there, and that's I want that there. So hard to see, but it's there. Okay, back to number 1. So this is my 3 high. So we're going to change to this. We're going to change to this, and then back to an elbow and a down because we're going to put a cargo container here. It should be right there. Alright. So now the problem is I don't have the materials. So one of the things that I really do need to build is my refining and assemblers. So you see the refinery here, and I'm going to go ahead and change it back over to Tiger Orange. Now, nothing really magical about refineries, so I'm going to go ahead and put the refineries up against the wall here. But I want to leave a gap, and the reason I want to leave a gap is because there's a port. There's an input port at the bottom, and I want both of those input ports to be sitting there. So we want a 1 square gap, and the reason why, maybe a 2 square gap. Let's go ahead and do 2. And the reason we want that gap in there is because I want to be able to hook the conveyor system in. So let's put one of them there and one of them here. Oh, and it actually let me build that. Then I'm going to reverse this like this, except I want a gap in between. So there's one there, and then I'm going to put another one right there. Okay, there's a reason for that. Why am I putting them like that? Like I said, there's a reason. So we're going to do the mirror on this side. Okay, so I want this on the deck. There's a gap of 1 and a gap of 2. Okay, and then the next one will go right there. The next thing I want to do is put this on the ground. Okay, so that's right up against the other one. I want to move out 1 square, which is here and here. Okay, so there's a gap in between. Now, why did I leave a gap in between? Because I'm going to put ESO modules in here. So let me go back up to all blocks. This is the ESO module, the upgrade module. I'm going to go ahead and put that over that and get rid of that. 3. Now, here's the downside. These things, as you can see, take 3,000 computers each. Now, we're going to be building, okay, 8 each, right? But they're 2-sided, which means I can get by on each side with 16 of these, okay? But 16. So, here we go. because I don't have nearly enough computers there. Those are going to sit kind of idle for a little while. All right, so one of the things that we really kind of want to do, and conveniently this lined up perfectly, which is great. So what we really need to do here is build in. So we got to connect it, right? So the conveyors here being what they are, number one. So the question is, how do we want to set these conveyor systems up? Now, I tend to want to bring everything up at least one. Why? Well, because I'm a space engineer and I need to do maintenance, right? Okay, so the only way I can do maintenance is to be able to get in and around and under things. Okay, so I can either pick these things up, which I didn't, or I can build my conveyor systems up. So I'm going to use a convention of building my conveyor systems up. So in this case, and then I'm going to put a junction here, and then I'm going to connect. So this is my connection to there, and then this is my connection here. And we're going to do the same thing on this side. So we have this, we have this. We're going to do the conveyor there. We're going to do the elbow here, and straight through, and then straight through. All right. So effectively what we've done is we have provided a path where all 8 in this case, or 2 groups of 2, can draw from the supply side. Okay, now what I mean by the supply side, these 2 containers are my raw materials containers. Okay, now normally I don't like to have my raw material side connected into my supply side. Okay, so these refineries in this case are not connected onto my supply grid. Okay, they are completely independent right now. So and this is purposeful. I want them this way. So my only connection in is from, you can kind of see the reticle there, is coming from that pull-in. In this case, I don't have a single pull-in sorter. I've got 2, one on each side, which can be a little bit problematic. Not always a good thing to have 2 independent systems, but in this case we do. And then that pull-in system will dump material into this container up until it's full. And we will draw out of that into the refinery, and then ideally on the other side of the refinery we would actually have a storage mechanism that would allow us to store these refined materials. And then the refined materials would then be able to draw off of my main storage. So I do a little bit of a different concept. Is obviously our assemblers need to be able to assemble. So here's what I am going to do. Now, assemblers, one of the interesting thing about assemblers is assemblers can do cooperative really well. The problem with assemblers is you have to run assemblers end to end to get them to run cooperatively. Okay, so if they're connected in any other way, they will not cooperate. Okay, they have to be end to end. So let me go ahead and go over to my number 3, bring up a G. Here's my assembler, and I'm going to go ahead and put that out there. In fact, let me go ahead and do my EZO. Just for sake of space saving, I'm going to go ahead and put these guys here. Now, how many assemblers do you need? Great question. It's really entirely up to you and your concept of how you want to build. I'm gonna try and do 5. So 1, 2, 3, 4, 5, 6, 7, 8, 10. 2 each. Okay, so I'm gonna flip this, and this will all make sense in a moment. And then here's our assembler. Turn our assembler sideways. Okay, remember that an assembler can have it has 8 upgrade ports. Okay, in this case, I'm going to string these assemblers end to end, and I'm arbitrarily starting at this end. So there's assembler 1, assembler 2, 3, 4, and 5. Now, remember, I said these guys have to be end to end to cooperate. I've just done that. Okay, end to end, which is really top to bottom, however you want to look at it, but end to end, over lengthwise. Now, I put the cubes on the back and the top. Now I'm going to do the same thing on the front and the bottom. In this case, I've already got it turned in this direction. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I'm going to flip this and do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. Now, what was the goal here? The goal was to be able to create a assembly array, an assembler array, that would be able to do cooperative engagement. Now, if I were really being intelligent about it, I would have actually sunk that into the ceiling. But, and I'm going to go ahead and do the same thing on the other side. Okay, so I'm 1 off from the end there. So I'm going to use that same methodology there. 3. Okay, so I'm 1 off from that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And we'll come up here to our ceiling. We'll flip that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We'll put our assemblers in. There's 1, 2, 3, 4, and 5, which are end to end, which is exactly what we want them to be. We'll shift back to the modules here. 2, 3, 4, 5, 6, 7, 8, 9, and 10. And we'll flip it sideways. 2, 3, 4, 5, 6, 7, 8, 9, and 10. There we are. All right. Now, here's one of the things that we're going to do, just a little bit of a modification here. We want to put in a conveyor here. Okay, and, we're going to change colors to our green. So this hideous color here, 313.2. The reason why it's a 0.2 is because you can't actually do a control on this one. One of those strange things. So I'm going to paint that. The build and repair system actually sees that color and says, oh, I'm going to grind that for you. That's my grind color. We're going to do the same thing over here. Show you why we did that there as well. Alright, change colors again back to my standard supply green. So we want to put that there. And in fact this here, we'll do the same thing on this side because we're kind of mirroring everything we do. That one there, this one here. We're going to change over to our straight through conveyor, also green, which is there. So that is the supply point for that array. This becomes the supply point for that array, and okay, so what did I accomplish with that? Well, I basically turned that entire assembly array into an interconnected thing. Okay, so now that is completely interconnected with the arrays, okay, or rather the storage. Okay, so the array is now, the assembly array is now interconnected with my storage, and we'll do the same thing on this side. So that was the goal here. So 2, I'm going to change that to this one, then the conveyor, we're going to be this one, that one, and then the elbow again. All right. Now, one of the problems that would normally be a game killer is what do we need for an assembler? And let me go ahead and look here. I'm going to highlight. So here's my assembler. So I need 80 computers and 40 construction components, which I do not have in my inventory. Now, I built things a little bit backwards. So 80 and 40. Okay, remember those numbers, 80 and 40 to build a single conveyor, or a single assembler. Inventory. Let's go ahead and bring up the entire inventory spectrum here, which is really to say container. Ignore the elsewhere containers, those are not really there. Okay, so what do I need? I need construction components and I need computers, right? Okay, but all of these computers were stolen by these guys when I built them because they need 3,000 each. Okay, so I kind of screwed myself, although the good news is I have the materials, the components I need in inventory. So I'm going to go ahead and build these guys. So I now have one. Oh, but I'm out of steel tubes. So I need just small steel tubes, okay, to build. So let's see if I have any small steel tubes. Apparently not. So let's go back into inventory. I need some iron. I'm going to go ahead and pull in 500 iron. Here's why. Because small steel tubes, now keeping in mind that this assembler is not connected to anything. It's got power, but it's not connected to anything. So in this case, I'm going to inventory. So that's my assembler inventory. I'm going to put inventory into that. So there's 500 into there. I'm going to go into production. The only assembler I have available is that one. And I need small steel tube. Okay. How many small steel tube do I need? Don't know. So let's build 100 of them. All right. So we'll go back into inventory. I'm going to pull 100 of those in. I've got motors, I've got interior plate and steel plate and construction components. So I should have everything I need to build conveyors and conveyor junctions. So there's this, there's this. All right, so now my assembler on this side is now connected in via this assembler to the storage. Okay, so now it can draw whatever it needs to build, and at the same time, because it's interconnected, it can also shove stuff out. All right, so the next goal is to do the same thing on this side. So there's that one, there's that one. Now the problem is the assembler. Okay, so I've got motors, steel plate, but I don't have any more computers. So the only way I can do this is to figure out which ones of these. So there was a bunch of computers there. So really I have to find the very first one that got built. Construction components, which I think was actually... Nope. There. Bazillion computers right there. So what I'm going to do is grind this down because I need all those computers. Okay, so inventory. I should have, yep, there we go. A bunch of those guys. I've got construction components. So here's what I want to do, and the reason I did that, I want to have 2 assemblers working. Okay, so 8. Get pointed on the assembler, which is just lacking computers. So there is my computers. Now I have 2 assemblers working. So I need a boatload of computers for this thing to do everything that it needs to do. So all I have to do is queue that up. So I'm going to go inventory. I'm going to my main storage. I'm actually going to put these computers, they're going to be gone because the build and repair system is going to steal them all. Like you see, they're just, boom, they're gone. So, displays, motors, which we can actually stack the motors there. Construction components, all of those are gone, and all those are gone. Okay, so we have a lot of materials here, which is good stuff, but we need to do production. So we have actually 2 assemblers now, and all these that are incomplete. So we have 2 assemblers. I want it to queue up, really in this case, computers. So I need gold and silicon. And because I need 3,000 for each one of those, I'm just going to click and keep going. So this is going to take a long, long time to build all these. But it'll take them, and then the build and repair system will actually utilize them as it goes. Let's go ahead and queue up. Actually, let's leave that one going. We'll bring up assembler 6, which is the one on the other side. And we'll go ahead and queue those up. We have some of those, and let's go ahead and queue up a bunch of bulletproof glass. So, the goal here is once you have that first assembler going, then you can start building these components that you need. That's really the goal. Once you have the materials, which I do, I did that all off screen, but boatload of materials in fact, now I can bring those in and start making the things that I need, which is what we're doing here. So once I get that first assembler online, so your first refinery is absolutely critical because you have to take those raw materials. Raw materials are abundant. Yeah, you have to go out and search for them, but I'm on a planet, they're everywhere, okay? So once I have those materials, I need to be able to take those and refine them into something, okay? So keeping in mind, I've solved my first two major criteria for survival. I have power and I have oxygen and hydrogen. Those are my absolutely critical two. You cannot survive without those two. You have to have those two. Okay. Then we need to have a way to take raw materials. Gathering raw materials is just tedious. Okay. You have a drill. It takes a while. You fill up your inventory. You come back. You dump it into something. Whether that be a container, hopefully, or a way to refine that material down and do something with it. So refinery. So in the case, in my case, I had a refinery and assembler. So the three things you need for survival is your assembler, your refinery, and your medical station. Now you have all three of those on the lander. So you can literally disassemble those, take all those components, which you get back at 100%. So as you take something apart, most of the time, batteries are the exception. There are other exceptions, but the batteries are the big exceptions. You can't take apart a battery. You lose the power cells, which of course are the critical components. So in that case, you disassemble your medical station. As soon as you have a place you can put another medical station, obviously the medical station gives you a place to spawn. If you don't have a place to spawn, then there could be some problems there. So medical station, when you have a place to move it to, then obviously dismantle it, move it. Then you have a place to spawn. You ultimately, to build, short of those first initial components, you get a lot of components by dismantling your craft. Okay, so in this case, I completely dismantled that lander, which gave me a bunch of materials. Once I dismantled that, the two things I needed to build was the very first refinery. Refineries, in fact, let's go ahead and look at a refinery. Okay, so refineries over here. Refinery, it takes 1,100 steel plate. Okay, that's a lot. Okay, but that's iron. Okay, you can make a boatload of steel plates. It's like 100 steel plates off of an ingot of iron or something like that. I might be wrong, but a lot of steel plates. Construction components, iron. Large steel tube, iron. Steel plate, iron. Okay, so you need 1,200 steel plates for a refinery. Okay, so building that first refinery really is not as hard as you think. Computers and motors are the only two things that are a little bit challenging, and motors, I believe, take nickel, iron, and well, let's look. Okay, let's go ahead. Oops, could have done it from over there. But, all right, so go into K. We're going to go into production. Motors. Motors take iron, nickel, and cobalt. Okay, so cobalt might be a little bit challenging to find. Iron is everywhere. So you'll find iron, nickel. So nickel, cobalt are going to be your challenges. But once you have those things, then you can make your motors. Computers, we need computers. Silicon and gold. Okay, gold is going to be a little bit challenging. But here's the bottom line. I can make all the motors I need. I can make all the computers I need. The only thing you will not find, and this is the challenge of survival at the beginning when you're trying to build stuff, the only thing you will not find on a planet surface, now there are some exceptions, but I'll get to those, is platinum. Okay, you're not going to find a deposit of platinum on a planet. Doesn't happen. So you're going to have to somehow get to space to get your platinum. That's really kind of the bottom line there. Okay, assembler 6 is done. So I'm going to go ahead and queue up a shit ton of computers because we need computers. If we're ever going to finish that other stuff, we need computers really badly. And because each one of those cubes takes 3,000 computers. This is just where the tediousness comes in. All right, let's look at some of these other things. Thruster components. Now, thruster components, platinum. Okay, so gold, which you can find, cobalt, which you can find, iron, very abundant. Okay, so all of those except for the platinum, you're going to be able to find on the planet's surface. So, thrusters. How do I get to space? I need thrusters. So, challenges being what they are. Large blocks. Okay, so if we translate things into various types of thrusters, if we can find them, here we go. Atmospherics.
Energy low.
So hydrogen thruster. So to build a hydrogen thruster, which can get us to space, is iron, nickel, and cobalt. So ironically the same thing that we would need for motors. Okay. So really it's the economies of scale, right? As we need components, our assemblers become that mechanism. But the assemblers need these raw components, in this case iron, nickel, and cobalt. If we have those, great, everything's fine, we queue it up, there it is. Otherwise, we have to go either search for it, and if we don't have a refinery, it might be a problem. Alright, what are some of the other things that we need to accomplish here? So for the pull-in system to function, we need to finish all this stuff. But over time, let's see what we need. We need construction components, small steel tube, and interior plate. Construction components, small steel tube. Okay, we really just need small steel tubes and interior plates. So let's get back into motors, production. Small steel tubes. So let's go ahead and queue up. Let's go ahead and say 5,000. Do 1,000. Well, kind of 1,000. And let's go ahead and have it start in here. But you see these are disappearing as fast as they come in. So the build and repair system is actually taking those as it gets them, and then it's going out and building all of these various components. So this is actually a good thing. So let me go ahead and queue up computers again. So queuing, for those of you who are new to Space Engineers, there's a couple of cheat keys. So whatever you happen to be building here, if you press it and left click, then it's going to add 1. If you press Control and left click, it will add 10. If you do a Shift and left click, it will add 100. If you do Control Shift, it will add 1,000. Okay, so you can actually cheat your way up pretty quickly. So with that queued, go back over to assembler 6, which is doing those. Let's go ahead and queue. Back to our computers. So the idea when you start really spooling up is to give your build and repair systems everything they need to build. Alright, so what have we accomplished? We accomplished the pull-in system and temporary storage. We accomplished, at least on the front side, we have our refining in place. Now we have to plumb it all in. The reason I didn't actually plumb that in is because I want to use sorters to pull the ingots out. Okay, so we still have stuff to do there. We set up our assembly arrays, one on each side, at 5 assemblers each. So we have 8 refineries, which should be fairly sufficient for everything that we're doing, and then 10 assembly arrays. For some reason the build and repair systems here are not taking these. Makes me wonder if these guys are not entirely on. Interior plate. The other thing that we're missing apparently is glass. Maybe I didn't queue up any bulletproof glass either. Production. Inventory. Let's go ahead and look everywhere. Glass. I have 730 glass, but it's not for some reason. Not finishing off glass. That one's done. Girder. I'm missing girders. Okay, production, and let's go ahead and queue up some girders. You can really never have enough. If you have the storage space for items, then you might as well queue it up and store it. We talked about the build and repair systems that are available, or rather the nanite-based systems. One is the build and repair system, the nanobot build and repair system it's called, by Dummy 09, I think, or maybe 08, in the workshop. Great stuff. The other one is that nanite control factory. One of the advantages of the nanite control factories, so let's talk about advantages. What's the advantage of the nanobot build and repair system? You can set up a grind color and a weld color, so you can actually just click on it, make it a particular whatever it is you're grinding, and the build and repair system will tear it down for you. The nanite control factory, on the other hand, has, I think, the neatest feature, which is auto queuing. So as the nanite control factory finds the things that it can build, it will actually auto queue the assemblers to build those items, which means then it will have the items it needs to build. So it auto queues, which is just cool. So if the build and repair system actually had an assembler auto queue system, it would be awesome. I would really like it. All right. So here's what I'm going to do here. I'm gonna actually create a hole in the deck here. So I'm gonna paint. I'm gonna line it up. There's actually 2 blocks, 1, 2, 3. I'm gonna go out to the 4th block. So 1, 2, 3, 4, 5, and then 1, 2, 3, 4. Why am I creating a hole this size? The reason for that is because the nanite control factory is really big. It's 3 by 3 at the base, and then the upgrade modules are 1 more. Okay, so 1, 2, 3. So I want to start here. Actually, I'm way over on my time, so I'm going to go ahead and do a break here, and when we come back, I hopefully will have the nanite control factories installed and built, and I will work overtime to get all of the components that I need for all of this stuff. So this is Kenty Tiger signing off. Thank you for watching, and we'll catch you next time.